Have you ever wondered about the workings of a car engine? Today we delve right into the heart of it. At the core of every engine you'll find the piston, the true powerhouse of the machine. This intricate component is responsible for converting the chemical energy and fuel into mechanical power. The piston is essentially a cylindrical piece of metal that moves up and down within a cylinder. This movement is what drives the engine's crankshaft, which in turn powers the vehicle. It's a beautiful symphony of precision and power, with the piston playing the lead role. This little powerhouse is a marvel of mechanical engineering, enduring temperature extremes and high pressure, all while firing thousands of times per minute. Now that we understand the pivotal role of the piston, let's explore the fascinating four-stroke cycle. The heart of a car engine beats with a four-stroke cycle. This cycle, which is critical to the engine's operation, consists of four stages: intake, compression, power, and exhaust. Let's start with the intake stroke. As the piston descends, it creates a vacuum, pulling in a mixture of air and fuel into the cylinder. This happens because the intake valve is open, allowing the air-fuel mix to rush in and fill the void. Next comes the compression stroke. With all valves closed tightly, the piston rises, squashing the air-fuel mixture into a tight little package. This compression increases the potential energy of the mixture, preparing it for the big bang that's about to occur. The power stroke is where the magic happens. The spark plug fires, igniting the compressed air-fuel mixture. The explosion from this ignition forces the piston back down with significant force. This power stroke is responsible for turning the crankshaft, which is connected to the piston via a connecting rod. Finally, we arrive at the exhaust stroke. The piston ascends once more, this time pushing out the spent exhaust gases through the open exhaust valves. It's like the engine exhaling after a hard day's work. These four strokes, intake, compression, power, and exhaust, form a continuous cycle that keeps the engine running. Each piston in the engine goes through this cycle, but not all at the same time. That's where the beauty of the engine design comes in. The pistons fire in a specific order to ensure smooth power delivery, with camshafts controlling the opening and closing of the valves to keep everything in sync. The crankshaft, camshafts, and timing belt or chain all rotate together, coordinating these actions like a well-rehearsed dance. But remember, this four-stroke cycle isn't a solo performance. It's part of a complex symphony that includes various supporting systems, all working together to make your car move. This cycle is the heart of any car engine, but it's not a solo act. Let's see how multiple pistons work together. Imagine an orchestra with each musician playing in harmony. The engine operates in a similar fashion. That's right, we're not talking about a solo act here. The engine's power comes from a team of pistons, all working together in perfect synchrony. Now let's dive a little deeper to understand how this mechanical symphony is conducted. Each piston performs its four-stroke cycle, but not all at the same time. The pistons fire in a specific order. This order, like the rhythm of a song, is crucial for smooth power delivery. An engine might fire pistons in a 1-3-4-2 sequence, for instance. So who's the conductor of this mechanical symphony? Well, that's where the camshafts come into play. The camshafts, fitted with specially shaped cams, open and close the valves in perfect sync with the piston movements. But that's not all. The camshafts, crankshaft, and timing belt or chain all rotate together. This synchrony ensures the precise coordination of the valve and piston actions. The crankshaft is another key player in our engine orchestra. It takes the power from the piston's up and down motion and turns it into rotational motion. The crankshaft is also designed with counterweights to balance the pistons, ensuring smooth and efficient revolutions. The engine block serves as the stage for this performance. It holds the crankshaft and cylinders. On top of this, the cylinder head houses the valves, ports, and cams. So there you have it. The engine is not just a bunch of metal parts moving together. It's a well-orchestrated performance, with each part playing its role to perfection. Each piston fires, the camshafts open and close valves, and the crankshaft spins, all in harmony to power your vehicle. So we've seen how pistons harmonize to power the engine. But what about the supporting systems that keep it running smoothly? Well, that's a story for another scene. Stay tuned. An engine needs more than just pistons to function. It needs a supporting cast. Let's start by exploring the air intake system. It's like the lungs of your engine, breathing in air for combustion. This system draws air in, passes it through a filter to remove any dust or debris, and then channels it into the intake manifold. Here it's mixed with fuel. creating a combustible mixture that's ready to be ignited within the cylinders. Speaking of fuel, let's talk about the fuel system. It's the engine's lifeline, supplying the gasoline that's essential for combustion. Like a reliable waiter, it pumps gas from the fuel tank, filters out any impurities, and delivers it to the fuel injectors. These injectors then spray the fuel into the intake ports, where it's mixed with the incoming air. Now, combustion generates a lot of heat. If not managed, this heat can cause serious damage. That's where the cooling system steps in. Think of it as the engine's personal air conditioner. It circulates coolant around the cylinders and through the cylinder heads, absorbing the heat produced during combustion. But collecting the heat is only half the job. The coolant then travels to the radiator, where it releases the heat into the atmosphere, keeping the engine at an optimal operating temperature. So the air intake system breathes in air, the fuel system provides the fuel, and the cooling system keeps everything cool. Together, these systems ensure that the engine can perform its 4-stroke cycles smoothly and efficiently. They're the unsung heroes that keep your engine running mile after mile. But our journey into the workings of an engine isn't over yet. Beyond the pistons and these supporting systems, there are other intricate systems at play. So far, we've covered the air intake, fuel and cooling systems, but there's more. The engine's performance also relies on its electrical system, alternator and oil system. Let's delve into these crucial components. First up, the engine's electrical system. It's the unsung hero, providing the spark needed to ignite the air-fuel mixture within the cylinders. At the heart of this system is the engine control module, or ECM, which is essentially the brain of your car. It controls the spark plugs, which are fired by the coil pack. This spark ignites the compressed air-fuel mixture, propelling the piston down and creating power. Without this well-timed spark, the engine simply wouldn't run. Next, we have the alternator. While the engine is running, the alternator is hard at work generating electricity. This electricity is used to charge the car's battery and power the electrical system, such as your headlights, radio, and air conditioning. The alternator is driven by a belt connected to the engine's crankshaft. As the engine runs, it turns the alternator, which in turn generates electricity. It's a vital piece of the puzzle, ensuring that your car has the power it needs to function. Lastly, there's the oil system, which plays a crucial role in the smooth operation of the engine. The oil system circulates oil throughout the engine, providing much-needed lubrication to the moving parts. This lubrication reduces friction and wear, helping to prolong the life of the engine. The oil is pumped through galleries, reaching every nook and cranny, ensuring that all moving parts are well lubricated. And to keep this oil clean, there's an oil filter that removes any contaminants that could cause damage. All these systems work in harmony to ensure the engine runs smoothly and efficiently. Each system plays a vital role, from providing the spark for combustion to generating electricity, and ensuring all moving parts are well lubricated. Finally, after all this power generation and combustion, there's one last system to cover: the exhaust system. After all that power generation and combustion, we're left with exhaust gases. But don't worry, the engine has this covered too. Once the power stroke is complete, the piston rises again for the exhaust stroke. The exhaust valves open, allowing the piston to push out the spent gases. This is where the exhaust system comes into play. The exhaust gases flow from the cylinders into the exhaust manifold, which collects the gases from each cylinder and funnels them into a single pipe. The gases then pass through the catalytic converter, which reduces harmful emissions by converting them into less harmful substances. Next, the gases flow into the muffler, designed to reduce noise produced by the exhaust process. Finally, the gases are expelled from the vehicle through the tailpipe. Now you have a better understanding of how a car engine works, from its beating heart, the pistons, to its efficient exhaust system. Keep exploring, keep learning, and remember, there's always more